take analysis titration process, which is complexometric titration. In general, complexometric titration, the sample is a metal and the indicator is a complexing agent. Now we are determining the calcium magnesium mixture. In this sample, we have two metals that we have to determine. Our titrant is gonna be EDTA, sample mixture of calcium and magnesium. Indicators, we're gonna use two different indicators, which is ABT in the first titration for determining the total, and meroxide in the second titration for determining the concentration of calcium only. Our titrant is gonna be EDTA forms with the calcium a more stable complex than it's the complex with magnesium. So it reacts with all the calcium, and then one excess drop of EDTA we're gonna react with magnesium and form the complex. In the first titration, our indicator is ABT. It forms with the magnesium a more stable complex than its complex with the calcium. So the color of the sample in the flask before titration is gonna be minor. While you are titrating, EDTA breaks with the magnesium ABT complex because it forms with the magnesium a more stable complex. Now ABT is liberated and became in the free state, and the color changed in the flask and became full blue. Now we know that we reached the end point. These are the procedure of the first titration process. This before titration, the color is wider. After titration and the ABT is liberated and became in free state, the color changed into full blue.
First, we start by washing our glassware with distilled water to avoid any metal ions in water. Washing our burette in the same way with water. Then washing it with our titrant, which is 0.1 molar EDTA. Now we will start filling our burette with our titrant, which is EDTA. Then adjusting it to the 0 point, making sure there is no air bubbles in the nozzle down. Now taking 10 ml of calcium magnesium mixture sample and putting it into our flask. Now applying 2 ml of ammonia buffer with a graded pipette and adding it to our flask. Adding few specks of EBT, which is our indicator, and it should give us wine red color before titration. A tip: when doing your titration, apply a white tissue or a white paper to see colors clearly. As soon as the end point is near, it will start turning into purple and then into the color we need to see, which is full blue. Note: when doing a complexometric titration, we titrate dropwise, since the reaction of color change is slow. Now you can see our needed color at the end point, which is full blue, and a reading of 14.2 milliliters.
The determination of calcium only, and in a new flask we put the mixture of calcium and magnesium, and we use an important mixture of NaOH. Why we use the mixture of NaOH? To precipitate magnesium in the form of magnesium hydroxide to be out of the medium of titration, so we can determine the concentration of calcium only. purple. Now, when we see the purple color, we know that we reached the endpoint. Here, the second titration process, the color of the chemical flask before titration, and here after we finish the titration, at the end point, when peroxide became in the free state.
In another flask, we add 10 millis of calcium magnesium mixture again, and then 2 millis of 8% NaOH to precipitate the magnesium away in the form of magnesium hydroxide. Now fuse peaks of peroxide to give us pink color, which is before titration. And again, by titrating dropwise, since the reaction of color change is slow in this compleximetry titration, until we reach our endpoint, which is purple color. Note, you need to take care of the difference between violet and purple color, since during the transition you will see both colors. Our endpoint is at purple, not violet. Endpoint reading at 6.2 millis.
Now we need to calculate the concentration of our mixture. So we're going to start with the concentration of magnesium, which is equal to the difference between the reading of the first titration, which is the total, and the second titration reading, which is the calcium only, multiplied by F small, which is a factor that is written on the bottom of the sample, multiplied by F capital, which is a constant given, multiplied by 1000 over 10 milliliters that we already used as a sample. Now we calculate the concentration of calcium only multiplied by F small, which is a factor written on the bottom of the sample, multiplied by F capital, which is a constant given in the equation, multiplied by 1000 over 10 millis, which is the millis used in the titration. First, we will use the first reading, which came as 14.2 minus 6.2, which is the second reading, multiplied by 1, which is the factor written on the bottom, multiplied by F capital, which is a constant. Multiply 1000 over 10, and in the second concentration of calcium, it's the second reading, which was 6.2 multiplied by 1, which is the factor written on the bottom, multiplied by F2, multiplied